Okay, so we're going to talk again today about equivalence. And what that means when it comes to fractions. So previously in our first lesson on fractions, we talked about what some fractions might look like. And so I'm going to divide this into 10 equal pieces. And we're going to pretend that that's equal. I'm going to fix that really quick. So I just want to let you know, I just drew my boxes really kind of funny looking. And so you're allowed to go back and erase and fix or whatever. There are no fraction police. Sometimes it helps to have them look the same size. So if you need to go back and erase, that's okay. It also does not have to be perfect. So I have a situation here where I have divided my whole rectangle into 10 equal pieces. I am going to color 4 of them, and nobody's writing anything right now. I just want you to watch me. I'm going to ask you some questions. So now that I have shaded 4 squares, what fraction have I got shaded right now? Jalen. 10/4? Natalie? 4/10. Yes, it's very easy to get it confused. It's okay. That's why we're learning. So the 4 tells us that's the numerator, and that tells us the shaded pieces. And the 10 tells us that's the denominator. That tells us the total number of pieces. Okay? So now we're going to talk about making a fraction equivalent to this. Okay? So if I have something that is the same size, and I divided it, not that way, I divided it, instead of into tenths, I divided it into fifths. So I don't have that horizontal line going across. I just have 5 equal parts. How many parts of this new shape do I need to shade to have an equivalent to the first shape? Brayden. Yes, 2. I need to shade 2. So I'm going to shade 2 right now. And we're going to talk about why that's equivalent. What is the fraction for this? Addison. 2 fifths. Okay. Are 4/10 and 2 fifths equivalent? Why? Sean. Right, the same amount is shaded. So if we pretended that these were cakes, and I took the cake and sliced it like this, and ate all of this, or if I took the cake and sliced it like this, and ate all of this, would I have eaten the same amount of cake? Yes. So we can express fractions in different ways and still say that they're equivalent. So we can say that 2 fifths equals 4/10. And you can do it the other way around. 4/10 equals 2 fifths. What do you notice about these two fractions? The difference between the two of them. What do you notice? Jonathan. All right, they have a different numerator. What else? Different denominators. Coral. Totally different numbers. They equal the same thing. Mason. So that's right. So what Mason said was 2 times 2 equals 4. And 5 times 2 equals 10. Right? With me? Well, didn't I take these 2/5 and divide each of them into 2 pieces? Yeah, right? Okay, so that's what I did. I multiplied by 2. So, we can say this. 2/5 times 2 over 2 equals 4 over 10. Whenever you do something like this and you multiply fractions this way, and you're making equivalent, you have to make sure that you multiply the numerator and the denominator by the same thing. If you don't do that, you got a problem. So my little rule for that is what you do to the top, and we'll be digging more into this later this week. What you do to the top, you must do to the bottom. So that's a really important rule. Okay? Now we're going to take this and we're going to kick it up a notch. And we're going to look at something that I like to call a tape diagram. And it doesn't actually involve tape. So one of the reasons I like this is because it kind of reminds me of a number line. And we've talked before about using number lines to help us add and subtract and figure out which numbers are bigger than the others. So that's one of the reasons why I like something called a tape diagram. So if I took this and I put one line right there, what would you call each of those sections in a fraction? 1/2. So each of these is 1/2, right? Okay. So what if I decided, I'm going to shade 1/2. Now I want to decompose these, which means break them down, to make fourths. How could I do that? Addison. Okay, so do you mean like about right here?
Yeah.
So I'm going to split each of the halves in half. So now what would you call each of these sections and fractions? Brayden. So together they're 2/4, but each one is what? This whole piece is 1/2. If I look at these individual pieces right here, how many total pieces do we have? 4. And one of them, what would the numerator be for one of them? 1/4. 1/4. 1/4. Not yet. Don't write yet. So let me ask about this. If I'm talking about equivalence, 1/2 equals how many fourths? Yes, look. 2/4, 1/4, 1/4 equals 1/2. 1/2 equals 2/4. Now, think about this that we did up here. What do I have to do to 1/2 to make it 2/4? What do I have to multiply by? Jonathan. Multiply by 2 on the top and the bottom, and I get 2/4. Okay, so that is an example of how we decompose this like this. Now, I can kick it up a notch, and I can do this. What do I have now? 8ths, right? So each piece is 1/8. So you're right, 4/8 equals 1/2. So I can say that 1/2 equals 4/8. Can I say that 2/4 equals 4/8? Why not? Is this still 2/4 that I have shaded? Sure it is. Right here. There's my 4ths. So you can say that 2/4, we divided each of those into 2 pieces each. That equals 4/8. That's where we're going to stop for right now before we dig into some more work. I want you to go ahead and get this in your math notebooks.